Okay, hey, we are going to dive into our new unit here in biology, and that is a little bit of biochemistry and life's reactions. Okay, now we're not going to get this can be a pretty in-depth topic, obviously, and we're just going to scratch the surface and kind of talk about some of the basics that high school biology student needs to know, and kind of what we need to um, just general what we should be understanding of as functioning adults in society today. So our first day here is basically just a little bit of a chemistry review. You probably have maybe seen or heard a lot of this before. That's great. You can skip ahead. But just in case, before we dive into more complex topics, we should all be in agreement on some of these. Let me go back. Some of these basics from chemistry here. Okay, so matter takes up space and has mass. That is the matter that we're talking about, and that is very, very basic definition of it there. When we talk about life, well, and non-living for that matter, it is composed of 91 naturally occurring basic elements. So think your periodic table, like the one behind me here. There's 91 that are elements that are naturally occurring. You might be thinking, hey, there's like 108 spots on there. What about the rest of them? Those are man-made. They're synthetic. They do not. We do not see them in nature there. And a reminder of those 91 elements cannot be broken down to substances with different chemical or physical properties in themselves. Okay, so we talk about cells as the building blocks of life. Elements are the building blocks of the universe, if you want to think of it from that way. So it's the most basic structure, the most basic atom, where it just has its one singular property there. I said, you guys know these ones: hydrogen, oxygen, carbon, those kind of things. How they relate to life: 6 elements, those 6 listed there, that would be carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, make up 98% of living tissue. Okay, now that's not like 98% of species, but of all, if you took all the biomass on Earth, 98% of that mass would be made of those 6 elements there. So carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Not in that order. Important to point out, just those 6 there. So same thing here. I like to show that we are made of those mainly those 6 basic things. Well, it turns out our universe is made out of those 6 basic things as well. Okay, so here's a look at elements found within the human body, with the green ones being the big ones that we talked about. And here's a look at what we see with those we look at for humans. Carbon, oxygen, hydrogen, nitrogen, that is 96.5% of your body weight are those things. Then you get calcium and phosphorus, that, think about your bones, but the majority of you is water, right? So hydrogen and oxygen, and then carbon and nitrogen make up the rest there. So tons of stuff there. And it turns out that those are some of the same most abundant elements that we see in the universe as well. So here are the top 10 abundant elements in the universe. Hydrogen's number 1. That's the same as go back to the human body. Hydrogen's in there. Helium. All right, so helium's inert. So helium doesn't form any compounds. It doesn't bond or make anything. So we can skip that. There's oxygen in there. Neon's just like helium in that noble gas category, so it doesn't make any bonds. And then we look and we see nitrogen, carbon, sulfur is on the list, silicone, which is not the same for us, but you can see that maybe as humans we aren't as special as we like to think we are. We're made out of some of the most basic ingredients that exist in our universe. Okay, some atom review here. Once again, this should be something that is you might just need a little brush up on. It should sound familiar to you. When we talk about atoms and how they behave, we need to talk about their subatomic particles. Do you guys know them? They're protons, neutrons, and electrons are the 3 that we're focusing on. Protons and neutrons are in the nucleus, and electrons move in those clouds around the nucleus. Protons carry a positive charge. Electrons carry a negative charge. Neutrons have no charge. All right. Once again, that should be pretty straightforward. And as a reminder, electrons are really small. So we don't give them a mass when we're talking about atomic mass units, whereas protons and neutrons, we do consider those. So when you are looking at your periodic table, the atomic mass of the element down here at the bottom is about equal to the sum of its protons and neutrons. So here we're looking at hydrogen, and notice that it's not just one; it's one with some fractional 7/1000 that is for mass. Remember, this is a weighted average, so the majority of hydrogen atoms just have one proton, but there are some hydrogen atoms that have a proton and a neutron, or maybe a proton and two neutrons, etc. So the number of neutrons can vary. We call those isotopes. That's going to come back later. The number of protons can't vary. Okay, so if it was an atom that had two protons, it wouldn't be hydrogen anymore. It'd be helium. So the atomic number is the number of protons. Atomic mass, that's the weighted average of, roughly how many protons and neutrons does that atom have. Okay. And then how are we going to use this? Okay, we're not going to talk a lot about elements. We are going to talk a lot about bonding, right? So we form different compounds. H2O is an easy example. Everyone knows about water. That is, two hydrogen hooked onto one oxygen. And so when we talk about molecules there, they either share electrons or they donate electrons to each other. And that gives us, we're going to be paying attention to that because your body's going to use that bonding process to store energy. Okay, so when we're talking about bonding, that's our secret to storing energy. Think about the ATP. We haven't talked about ATP yet. Think about the mitochondria and it breaking down different sugars and creating this new thing called ATP, where it's storing those chemical bonds in there. So for bonding for us, we can share bonds, we can share electrons, we can donate electrons, but that is going to be kind of the secret to storing energy in cells. Okay, don't worry about the molecule building. We're going to stop right there before we get into some of the large macromolecules of life. So there's part one of just a little bit of a chemistry review for you for our BioChem unit.